Hi, today I'm going to talk about upper bound, lower bound, maximum and minimum of subsets of R. So for convenience, I will denote S as a non-empty subset of R. And in the first section of the video, we are going to introduce upper bound and lower bound first, and in the second part of the video, we will going to introduce maximum and minimum. So let's define what upper bound and lower bound first. So let R be a real number. If L is said to be a upper bound of S, it means that for all x inside S, L is greater than or equal to x. And on the other hand, if we call a real number L a lower bound of S, we mean that for all x inside S, we have L smaller than or equal to x. Well, there is something you have to note. First of all, the upper bound and the lower bound are not unique. That means there can be more than one upper bound or lower bound for the same set. So let's do an example. For example, if we are given a closed and bounded interval 0, 1, we say that the set of upper bound of 0, 1 is the closed and bounded the closed interval 1 to infinity. On the other hand, the set of lower bound of 0, 1 should be from negative infinity to 0 included. So, from this example, we can clearly see that not even unique, but there are infinitely many upper bounds and lower bounds. Although sometimes there are infinitely many upper bound and lower bound, but there are some cases where there is no upper bound and lower bound. For example, for the closed interval 0 to infinity, the set of upper bound is indeed empty set. What's the reason behind? Well, suppose such interval has an upper bound, and we call it mu. So, from the definition of upper bound, we have that mu is greater than or equal to x for all x inside the interval. In particular, 1 lies inside the interval. So, we have mu greater than 1 greater than 0. And we call this statement star first. And if mu is greater than 0, then after we multiply mu by 2, then this number is still 0. It's still greater than 0. So, by the definition of 0 infinity, and recall this definition. This is the definition of this interval. And so, we have 2 mu lies inside 0 to infinity. And recall that mu is greater than or equal to x for all x inside this interval. Therefore, we can replace this x by 2 mu, because 2 mu indeed lies in this interval. But if we get this inequality and we subtract mu to both sides, we get 0 is greater than or equal to mu. But remember, we have marked a star here. We say that mu is greater than 0. Right? So these two statements are contradictory. And so what can explain this contradiction? Yes, it is the assumption that we made is wrong. So indeed, there is no upper bound because we assume that there is upper bound. And for the second one, the lower bound of this interval, I will leave it as exercise, which is I leave it as exercise because it is similar to the proof before. And there are some terminologies. So the first terminology is that if the set of upper bound is non-empty, or you can translate to daily life language that if the set has upper bound, we call this set bounded above. And on the other hand, if the set of lower bound is non-empty, we call as a bounded below set. And if S is both bounded above and bounded below, we call S a bounded set. And the last but not least, if S has no upper bound or lower bound, we say that S is unbounded. For example, we consider the set of all integers. Well, the set of all integers includes all negative integers and the positive integers, as therefore there is no upper bound or and lower bound for the set of all integers, and therefore the Z is unbounded. On the other hand, remember that we studied the case of the closed and bounded interval 0, 1. And why we call it closed and bounded? Because it is indeed bounded from our definition above. Okay, so this is the end of the video about upper bound and lower bound, and we will see you in the next video, which is going to talk about the maximum and minimum.